أبو هشام from Bishti. I work especially on performance and durability of PV module. Today I'm going to talk about PV module durability in desert condition in order to develop and to optimize photovoltaic module for desert condition. So, as you know, if we work for a PV system, there is a lot of harsh conditions that can affect the durability of PV module. Talking about UV light, temperature cycle, corrosion, etc. So our objective is to investigate a PV system deployed in the real climatic condition of Morocco in order to understand and to develop a PV module which can prevent the dominant degradation mode in Morocco and to improve the durability and the performance of PV module based on different technique of inspection. So if we talk about the PV module years, in a PV module there is 5 years. The first one is the PV cells between 2 layers in the front side and 2 layers in the back side. If we can expose this PV module in the real condition, it can have different degradation mode related to climatic condition of operation. For example, as I said, UV light, etc. So if we can detect the defects in each layers, by the way, we can propose and we can optimize new conception and new design which can prevent this defect in the real specific condition. As you know, recently there is a lot of PV module deployed in the market, but not specific for each climatic condition of operation. There is a PV module for temperature condition, for molecular condition, etc. But there is not a specific PV module for desert condition. As you know, desert condition, we have solar radiation. However, we have harsh condition. If we can deploy and investigate and operate and elaborate PV module in real condition, we can of course investigate and tolerate about the different defects and real condition in this real defect in this condition, and then we can propose and improve the durability. So if we are going to inspect and to monitor the PV module in real condition, we have a lot of techniques. We have firstly the visual inspection, but there is some defect which cannot detect with visual inspection. So we should use powerful techniques like electroluminescence, infrared, and electrical parameter measurement. So we have worked at the Green Energy Park facility in Bengurir. So based on 5 PV systems, especially crystalline PV systems with different technology, monocrystalline and polycrystalline. And based on this PV module, we have detect and specify the dominance defects in the climatic condition of Morocco case study in Bengurir. So we have the so-called hotspot. Hotspot is a specific inhomogeneous distribution of temperature in the PV module. We have the so-called illumination. Illumination means that there is a penetration of humidity between the different layers of the PV module. We have the snare trails. Snare trails is just nomination of trails that there is a defect like the snare trails. We have discoloration. Discoloration is a modification of the color of the front side layer. We have cracks. Cracks is a fissuration of the PV cells which cannot detected visually, and we have to use electroluminescence to detect such defect, and we have the so-called PID, potential induced degradation. So we have just 8 minutes. We cannot elaborate in different defects. We can just talk about hotspots. What is the source of hotspots? Hotspots, we have particularly three methods or three methods to or three type to have a hotspot in the PV module. The first one, the inhomogeneous dust accumulation of the PV module. If we have inhomogeneous dust accumulation in the PV module, we have, of course, partial shading of a PV cell. As you know, in a PV module, we have cells connected in series. If we have, for example, shade one PV cell, we cannot work as generator but as receptor. Okay, then they can of course emit thermal energy as problem. So by the way, we have the hotspot. The second test is the defect in the PV cell. If we have a PV cell, a defect in a PV cell, we have of course an homogeneous generated current in the PV module. By the way, we will have the hotspot. And finally, if we have a problem in the bypass diode, the bypass diode is a shunted bypass diode with the cells that we can of course prevent defects in a part of the PV cells if we have problem. So as you see here in this picture, there is a hotspot in the green energy park facility in green. So as you can see here, we have elevated temperature in some parts of the PV module, which demonstrates and elaborate that there is a defect in the PV module. So to detect this defect, we can take AR camera to this defect. We can of course work with drones to detect hotspots if we are working on a large scale. Okay, so parallel to that, we have of course the so-called degradation rate. So this is the degradation rate of the 5 PV system investigated in our work. For the PV system number 1, the degradation rate is about 2.5% per year. That means that there is a losses of 2.5% each year of operation. After 25 years, especially as recommended by the manufacturer, we should not have more than 0.8% per year. However, in this investigation, we have high degradation rate that demonstrates that the climatic condition of desert climate can affect the durability and the performance of the PV module. So to demonstrate this results investigated in Morocco, this is an article published by Jordan and Kars from the INRIL laboratory that demonstrates that in desert condition we have high degradation rates which can go up to 4% per year. 4% per year means that there is a 20% of degradation after just five years. So our objective is to elaborate to improve the durability in order to improve the levelized cycle of levelized cost of energy from the module. So in order to do that, we have to elaborate to minimize and prevent this defect, this dominance defect in Morocco. Let's just talk about, for example, the problem of PID. So if we are talking about PID, PID is a problem between the cell and the frame of the PV module. That means that there is a current, a flow current between the cell and the frame of the module. However, we have a layer that isolates electrically the cell with the frame. However, so under the effect of voltage, we can find the mitigation of charge between the cell and the frame, and we can, by the way, find the problem of the eye. As a solution, we have proposed an alternative layer which is called polyethylene in the place of ADA. ADA have approximately a resistivity of 10% 14. However, polyethylene layer have high resistivity, which can improve resistivity of the layers against the flow of current in the PV module. So we investigate each defect separately, but I cannot discuss all that in this presentation. So I will go directly for the proposed connection for our PV module. So this is the proposed PV module to elaborate and to prevent PV degradation in desert climatic condition of Morocco. For the front side, we have proposed glass plus anti-soiling coating to prevent the adhesion of soiling on the PV module, plus UV cut. UV cut is a layer to prevent the penetration of UV light in the PV module. We have also proposed the polyfilling layer in the place of EVA. For the cells, we have proposed the PERC cells, pacified emitter plate contact have cells with 4 base bars, the polyfilling in the backside, and the backshed with aluminum mid layers to prevent the penetration of currents in the front of the PV module. So generally, as we exposed in this presentation, we have seen that there is a lot of degradation and a lot of impact of the climatic condition of desert condition on the PV module, and we need to investigate this defect, to propose solution and to propose a PV module for desert condition. So thank you for your attention. Not general UV rays and temperature. We have elaborated the different climatic condition in real condition, not in simulation.
Okay.
Yeah.
The question is, in the desert area, there is not a big problem. Is the sand, dust, and wind causes a lot of loss in the panels. Have you tried to study this problem?
So for me, I studied this problem of dust, but just with my colleagues in the Green Energy Park. There is a lot of colleagues which have been elaborated there. We have with us Professor Ala Azuzut that have elaborated in this topic.
I was visiting some country, I don't remember when, the power plant of the sort of thing. There is one big power plant.
Yeah, in which there was one. Yeah.
They are doing the program of cleaning this PV panels.
This PV panels, yeah.
Of the dust, and there is a reduction of efficiency of this.
Yeah.
They are not PV panels with the system, but thermosolar panels.
Yeah, for CES solar for CES concentrated solar power.
Some countries use offshore power plant systems. They solve 2 problems. The first one is low temperature.
Floating
PV. There's low temperature.
Low temperature. Yeah.
And the second one, there's no dust. Sand.
Yeah. That's a solution that can be implemented in the large scale PV system. Yeah.
Okay. Is there another question? No. Okay. Thank you.